Hello. In today's session, we are going to look at a technique of feature engineering called one-hot encoding. And we are going to make use of the healthcare stroke dataset that is found on Kigo. And we are going to look on the technique of using get dummies, and also we are also going to look at LabelEncoder. So the first thing that we need to do is to import our libraries, and we are going to make use of the Pandas and the sklearn.preprocessing module to do with one-hot encoding and LabelEncoder. So we execute that cell, and then the next thing is to import your dataset, and we also execute that. Once you have imported your dataset, the next step that you want to do is to explore the dataset by using an EDA and making use of the head function. And this is how our dataset looks like. And now we want to focus on one-hot encoding, and we are going to focus on the Jupyter feature. So if we go to the Jupyter feature, dataset dot Jupyter, and we call the unique function, we are going to see that we have got 3 items there, which are the categories that are found inside the Jupyter feature, and we need to convert these categorical features into binary, which helps the model, because the model likes and performs better and well when dealing with numerical data. So to do that, what we are going to do, we are not concerned in this session with trying to map the data or to clean that data, that feature, where we have got the other, in terms of correcting if there are any errors inside the feature. We are not concerned with that. We have already done that in our previous sessions when we were looking at data scrubbing. So if you want to see how you can clean this data set, you then want to look into the previous video on data scrubbing. So what we just want concerned with is converting the categorical data into one-hot encoded column. So to do that, it's simple. What we just want to do is we create a new data set, and let's call that data set 1, and then we call our data, our pandas. From pandas, we call our get dummies, and then we call in our data set data set, and then we have to specify the column that we want to use or to encode, and we are going to work with the Jupyter. And then we are going to force our kernel to change its data type to int. Then we execute the cell. We call our dataset. Call our dataset one dot head, and then as we look into our dataset, we can see that dataset 1 now has got another column here, additional columns, which is gender female and gender male. As you can see there, it is added wherever there is a gender female, it's indicated by 1, where it says it is a female, and 0 represents that is not a female. But as you can look here, you can see that what has happened is that it has created for each unique category that is found in the gender column or the feature, it has been created as a new feature, which is ending up exploding or increasing our data set. This can be costly in terms of resources, in terms of how the machine model is going to process, and we don't want such a scenario because it ends up creating a problem of what we call multicolority. So what you would want to do is then to remove one of the first feature, because these features, they are correlated to each other and they represent the same information. So what you want to do is you would want to do it by, let's say, creating another new data set, say data set 2, and then we call our PD and get dummies. And okay, let's just copy this and bring it down. And what we want to do is we want to add another parameter here by saying drop first, and then we assign that true. Okay, so what we are doing is then we are letting get dummies drop the first feature so that we remain with 1, as we can still deduce the same information from one column instead of us having many columns or many features being added to do the same thing. So we execute that, and then we call our dataset 2, and we view to see, let's just say .head, so that we only get the first 5 rows. So here we are. So as you can see there, we have our gender male instead of having gender female and gender male, and because of we also have another column which is other there, we end up also having the other column that is there. So, but eventually you can see that we have removed another feature and we have reduced its size. So if we had first of all cleaned our data set and removed the other, we would have remained with only an additional of one feature. And if you are going to be working around with one-hot encoding using get dummies, you find that the challenges that you are going to face is to do with creating more features. You can imagine if you had different categories, maybe more than 6 categories inside one feature. Let me say those 6 categories, you would end up having more 5 features being created in your data set. So that's the problem with get dummies, and its impact is that it increases the memory usage and slows computational power, and also makes your model less efficient. And the only way you can try to get around when we have got more categories inside one feature is to try to use label encoding. So let's look at how you can use label encoding. Label encoding. Let's say a label encoder. Okay, change that to Markdown. And let's go back to our original data set. So this is our original data set, and let's also look at maybe smoking. Let's see how it looks with smoking. The smoking status. So let's go again through data set dot smoking dot unique. So we can clearly see here that these are the different categories that we have under the feature status, smoking status. So we have got formerly smoked, never smoked, smokes, and they are none. So if we are going to use get dummies on this feature, we will end up adding an extra 3 more columns in our data set, so that we are expanding our data set. That is one of the problems that we have when we are using get dummies. So let's see how a LabelEncoder will try to solve this situation that we have. To do that, what we are going to do is we are going to say create a new data set. Let's say data set 3_3, and then we are going to copy the original data set by using the copy function. Okay, so now we are going to say data3.head. Okay, and you can see it's the same copy as the original data set. So we are going to work in this new data set instead of working on the original, so that we can continue using the original data set that we have. And now let's go on to encode and see how we can do that. So to encode, we say let's create a variable label encode, and then we call in our LabelEncoder. So we instantiate that, and then we are going to say specify the columns that we want. Let's say columns to encode, and we pass through the array of columns to encode, and we want to deal with smoking status. So we want to deal with smoking status, and the next thing after we have created the columns to encode is that we can then go ahead and encode. So let's also just add another one. If you need to add more columns, you can always pass them through here. So let's just go ahead and use the Jupyter again. Jupyter. And because we have got more columns, let's use the for loop for column in columns to encode, and then our data set 3, that is what we're going to use, and then we want it to create a column. We say LabelEncoder, which is the variable that we created on top. Okay, so you can see that it has got a capital letter there. We are going to use this, but remember, you don't want to add a variable using a capital letter in the beginning for standard sake. We call our fit transform the data, and then we want to pass through our data set. Let's call our data set 3, and we want to pass the column. And then we execute the cell, and then we want to now call our dataset 3 to see how it looks like. Say .head. Okay. Let's check to see if it is encoded. We were working with the smoking status. So if you go and check the smoking status there as a feature, you can see that it is now encoded into numerical values for each category that we have. It has been given as a certain category instead of us expanding the feature, whereby you would say for each unique category you edit as a feature. It is given it an order that is 0, 1, 2, 3 for each feature going upwards. And we also did the same for gender. You can see that it has converted that to numeric also for all the values that are there, and it will remain still with the same feature that we had, but now the feature has been encoded. So you'll find that the challenge that you have when you're using LabelEncoder is that it ranks these categories as if they have got some preference, whereby you'll find that when you're dealing with the machine trying to create a model, it might look like the category that has been given a value of 1 might be more important than the value 2, and what is the value 2 is more important than value 3. So this is the challenge that you are going to be working with, and you need to understand when you are doing your one-hot encoding whether it's going to affect your model or not. The other feature that you might want to apply when you are dealing with one-hot encoding is maybe to use the sklearn.preprocessing one-hot encoder to convert also your categorical feature into numeric. So this is how you would want to work around one-hot encoding or converting of categorical features into numeric inside your Python Jupyter notebook. Thank you.